Evening. So we'll start today with your entertainment program for the morning is Ripe Atlas. Oh, actually, Dave. No, we're not going to start because I need Ripe Atlas probes.
Sorry?
This was a false start. I need 1 minute to get Ripe Atlas probes here. So. Yesterday at the tour we learned that nothing is perfect, right? So this was. Let's see. Yeah. Okay, so Ripe Atlas for network researchers. So my name is Emile Aben. I work at Ripe NCC. And I don't know how many of you have seen this picture before.
It's the world.
It's the world, yes. But what are the green dots? Probes, but green and red.
Anchors.
Sorry?
Anchors?
No, anchors. But no. So green is connected, red is disconnected. So each of these represents one of these devices, and actually, as you can see, it's worldwide. And this one I'm particularly proud of. It's Svalbard. It's like Norway, Russian. It's weird jurisdiction, but we actually have a probe there, and it looks like this. So this is actually an old version. So that is. Ripe Atlas is this very distributed system to measure. But before you measure, this is a slide I showed yesterday. I hope everybody got their credits on the system. If not, we can still fix it in the break. Well, I created a little diversion here for people who still wanted to do credits to tell a little bit about the organization I work for, because we are not a research institute per se. But we do support research. What we actually do is we distribute number resources, so IP addresses and autonomous systems. There's 5 organizations like us doing this worldwide, and we are this yellow blob here. So it goes from Greenland all the way to Vladivostok, to so former Soviet, Middle East, up until Iran. And Europe. And we're headquartered in Amsterdam, which is where we do our stuff out of. Have a side office in Dubai. But what do we actually have to do with research? So we're a membership organization. Our members are the network operators, so the people that use the IP addresses and autonomous systems. And as an extra service to them, we have data services like RipeRIS, which was discussed yesterday already, which is one of the sources for BGP Stream. And the other one is, of course, Ripe Atlas, which I'm going to talk about today. And we have a couple of people working on random research ideas of use to network operations. So what we actually want to do is make network operations useful for research and research useful for network operations. So that's where we hope to play a role. And I'm part of that team, and I'm actually, one of my roles is to get out and meet as many of you as possible, talk about crazy research ideas we have, that you have, and see if we can do something useful for the internet, for the good of the internet. So, what is Ripe Atlas exactly? We have a Wikipedia page, so I actually don't have to explain what it is. You can just look it up on the internet, and we can all go drink coffee. But I think many of you have used Ripe Atlas before. Maybe how many of you have used more than 1 million credits on Ripe Atlas? Okay, so you can actually come do the lecture, because so, and how many know of the system? Okay, no, have used it a little bit maybe? Okay, so half, is that kind of? So I'll just do like an overview of the system. If anybody at any point wants to interrupt me and, hey, this is cool, or can you go faster, slower? I really want this to be interactive to get the most out of this session for you in gathering information on what the system actually is. So please interrupt me if I go too fast, too slow, if you have a segue, which is really cool. So again, what is Ripe Atlas? We want to improve the internet through measurements. We want to know better what this internet thing actually is. And we do that by providing an infrastructure of roughly 10,000 of these, if you round it up. And these things are all hosted by volunteers. So it is a system for the community, by the community. And the data coming off of it is publicly available. So that's also very important to us and to the RIPE community. So actually, I work at, the organization is called the RIPE NCC, but we do work for the RIPE community. The community is everybody who cares about the internet in our regions, in our service region, and also beyond the service region. So if you're not from that service region, don't feel restricted. Don't feel restricted by that. Well, I showed the map already. So these are actually the devices. We had some, you saw the little small device that I showed for Svalbard. This is the current version of it. I actually have 10 with me. I like to distribute them to places where we're not already, and I'll show you a little bit what I mean by that. But you can also find the map that I showed online on atlas.ripe.net, our website. So what's nice about these is they're small boxes. You just plug in Ethernet. It does DHCP, or you can configure it yourself, and it just starts measuring. So by default, there's some built-in measurements that are already running as soon as you got the system up. And you get credits. You get credits by hosting one of these to actually use the system, use other devices to do your measurements, to do your active measurements, basically. We also have a bigger version of this. It's a 1U, so it's about yay big. It's a Sutris, and it's called the Ripe Atlas Anchor, and I'll show you a little bit more about it in a bit. And we got requests for virtual probes, and there's a lot of back and forth about, is this useful, is this not useful? One problem with virtualization is that it's hard to get a good sense of the timing accuracy. If you're really into really accurate RTTs, for instance, what's the difference if you take it on a virtual box? Actually had a good discussion with Monroe, with Usku, that they actually do this virtualization and they don't see any difference between their virtual version or a real version. So I don't know if we have any virtualization experts here. No hands. Try to make it interactive, but it isn't working. This people are worried that this virtualization will make our timing and our data will pollute it in some sense, in that it's not accurate anymore. But we could get stuff into like Amazon, any place where you can only get virtual probes. Typically, we don't have probes in big networks like Facebook or Amazon or any of these, just because they just don't allow physical hardware to be installed into their networks. There's FIPS and all kinds of, I don't know what the regulations actually are called, but if you do stuff with banking, then people are really, really worried about getting physical devices in, whereas like a software image is doable for these. So there's trade-offs there, and maybe some people would install a virtual probe and then they don't install an actual hardware device where you have far more control over the parameters under which your measurements are taken. So if people have ideas on how to actually, if there's middle grounds, because I could think that if you have metrics on the host systems, you can sort of make assertions on how accurate the data is that comes out of this. Or if you're only interested in a path, or if you're only interested in what's the DNS answer from this particular part of the network topology, then these types of virtual things are actually interesting. So let me get a little bit of an overview of how the system actually works. And so you as a user are here. You have multiple ways to interact with RIPE Atlas. There's a web interface, there's an API, and there's a command line that uses the API, and the web interface of course also uses the API under the hood, but that's details. Through these you have control over these devices. There's a middle layer that's run by a couple of very capable people at the RIPE NCC, and via these interfaces you specify what types of things the probes and the anchors are actually doing. So this is another way to, so as a user, you go to web interface, you specify, I want 10 probes in Germany to measure www.google.com, and I want this to be a ping measurement over IPv6. And since Germany has a lot of IPv6 enabled probes, the system looks if it can actually fulfill this request, and if it can, it will just send these commands out to the probes over a control channel that is open. They will, in this case, then go to www.google.com, do the ping measurements, and report back what the results are. It's you saw a similar system with Monroe yesterday. So we actually have 6 types of where it's quite different from Monroe is that Monroe you specify your Docker image, all kinds of parameters. This is more restricted in you have 6 types of measurements. There's ping, so it's pure latency, and you can actually do that over ICMP, UDP, or TCP. I guess ping is not a curse word here, right? Trace route, so you do path measurements. It's a Paris trace route by default. You do DNS measurements, so you actually specify this probe wants to ask a server what's the answer for this particular DNS query, or you can ask use the probe's resolvers that are configured to get a DNS answer. That's not another type of DNS measurement. SSL TLS, it just does a certificate fetch. So you can do all kinds of things with give me 1,000 probes and see if the certificate for this particular endpoint is consistent. NTP measurements, I don't know much about NTP to be honest, but there's all kinds of interesting things. We had a leap second, for instance, beginning of this year, and one of my colleagues actually wrote a really interesting analysis on what actually happened there through the DNS, the NTP measurements that are in our system. You can specify them yourself as well. And HTTP measurements. And here we have a bit of a problem with HTTP measurements. Because we're so widely distributed, we don't know what's legal or illegal to do in a country. So we do GET requests, but a GET of really illegal content from certain parts of the country could get people in jail. So we definitely don't want people to get in jail. And we really want the people that use the system to be aware that this type of thing, that there's an ethical component to doing measurements. So for HTTP, we just said, even with well-educated users, the risk is still too great. So we don't do that, except from the probes to the anchors. So you can actually do HTTP measurements, HTTP gets, but it's very restricted in what you can do. If you have a really good research idea and it's we're 100% sure this is not going to harm somebody, you can actually ask us, and then on a case-by-case basis we can see if this is actually something that we're willing to entertain. Did I say everything about that? But another thing with what you typically want us, part of what you want to do with HTTP measurements is just a latency measurement of your TCP service. So you can actually do a TCP ping. Or you can actually have a trace route where you set the initial TTL to very high, so you're reaching destination immediately. These are all little tricks that you can actually do to get at least latency measurements to an application, to a layer 4 thing. You cannot get the stuff up from that level, but at least there you can get all kinds of latency and loss metrics that will affect how your users actually see an HTTP fetch. Yeah, so we have APIs, command line tools to start measurements and get results. I'll show these. Streaming, we have people want real-time access to this data, and typically you'll have to schedule measurements, wait for results. And in this case, you just connect to a WebSocket, and you'll just get, it's drinking from the fire hose. You get a big fire hose of measurements pointed towards you, and you're the one who's responsible for keeping up with that. Time travel, you can actually, if you have specified a measurement and there's visualizations on the website, you can actually say, okay, what did it look like a month ago, 2 months ago? Latency mon is a visualization to show what the latency was over time. Domain mon is a DNS specific service where you can actually see how your DNS is doing. And I think that's more interesting for DNS operators, or maybe DNS researchers might be interested there as well. Status checks, so you can actually check for a service. You specify 10 probes to go to a specific service you want to check, and here you can specify Asinga and Nagios type checks for this particular service. And this is a relatively new thing. This is like my colleague Massimo Candela from Roma 3. So that's an Italian connection. I noticed there's a lot of Italians here. So this is another Italian connection. And a bit unfortunate that I didn't put resolution too high. If you have like a measurement like Rapat was specified, if it's a trace route, this will actually sort of visualize that as a tree with all kinds of nice, rich annotations of what it is you actually have. So this is a trace route of can I count 7 probes towards Google, and you can actually here it has the autonomous systems. In blue you have the exchange points. So that one's let me just read it from here. That's AnalIX, the next one is FranceIX, and the next one is AMSIX. and here's a Singapore one. So you can actually see this goes through a lot of exchange points, and here it's annotated with Google. So you can actually see, well, below the exchange points, everything is Google. So you know these probes get to Google through these exchange points. So it's not very surprising, but it's nice to actually see how this thing works. And here's like a latency graph of the destination. So if you do this measurement periodically, so if there's something weird going on with latencies, you can see it here. You can then sort of put your put a slider here and see what the situation was at this weird point. So this is like a data digging tool. And you can also see, for instance, if you cannot reach the destination. So it's very nice work, and I invite people to actually play with it and give us feedback on what new things you would want from a system like this. So, talked about interfaces. Well, slides are going to be up on the website. So this is more a reference. So you have a web interface. So atlas.ripe.net. I mean, if you want to play with it, just open your laptop, type that. If you're logged in, you can see the whole system and find stuff. I heard that it's a little challenging to find the right documentation for the right things, and actually, I agree a little bit. It is sometimes hard to find it, but it's also because it's a quite big system at this point. There's just documentation about stuff that I'm not going to talk about here. You can all find it here. API, we actually had version 2 of the API. Version 1 it worked, but now it's all built on top of like stuff that's more reusable, and it's Swagger, is that? Swagger based, so you can actually do, if you go here, for instance, for probes, for measurements, you can actually play with what parameters of an API you can use. You can actually try it out there, which is really nice. And here's a manual, and we have a command line interface which you can install from here, where you can just say ripe atlas report a measurement ID, and it will just show you stuff about. So it's catering to all kinds of different needs. So for the people who have used ripe atlas, I guess everybody used the web UI at some point. Everybody used the API as well? Kind of-ish. Command line interface, anybody used it? No? Okay. Low battery, oh. Maybe, yes. Okay, yeah, so that's what the interface looks like. So 97,000. This morning when I looked, it was 9,800. So we're still trying to get to this magical 10,000 devices deployed. And there's 20K measurements running, and it's this many results per second, so 4K results per second. So that's, if you connect to the stream, that's the type of data, and a result is a thing between a source and destination or a trace route. So it's it's interesting to try to keep up. Let's put it that way. Programming interfaces. So if you use this API, you don't have to do it all yourself. It's RESTful, so you get, you post, it's all JSON structure based. But there's actually ripe atlas Cousteau, so that's interfacing with it. This is in Python, and I'll show an example of that later. There's also ripe atlas Sagan that's interfacing with the results coming out of the system. The results are all in JSON. So if you're, you can parse JSON with anything you want. My personal preference is to just get the JSON and to actually see what's in these and then parse it. But for the people who are more like object-oriented interface, everything has to have a like consistent name type of person. Then this is your the thing to be using. We actually have a lot of community contributions which are here on the GitHub. So if you have written your own thing which you think is interesting for other people, then this is a place where you can put it and get some other people to work on it. So let's get to the probes. I'm not a hardware guy, but this might get some hardware people a better feel for what these devices are. And actually, we started off with these little ones. Actually, so that's the whole measurement device. And actually, this is I thought this is the coolest version ever. Unfortunately, it's really hard. Memory fragments, and you have to do a whole kind of. It's a pain to actually program these, but they're really nice because you can just put them. My probe at home, for instance, is behind a rack full of toys for my kids, and I don't have to touch it ever. And this one is just too big for that. This one just fits. So. So this is a Lantronix Export Pro. So that's the version 1 and version 2 probes. This versioning is important because they have different characteristics. There's actually a measurement paper in IMC 2015. Thomas Holterbach is a primary author that shows that if you load these with incoming or outbound measurements, that the performance degrades, and yes, it's a fact of life. The version 3, so that's these. They do way better. So if you are really wanting to optimize for getting the most accurate results as possible, use the version 3 probes in your measurements. And these are the TP-Link model number. They're powered from the USB port. Well, they have an extra USB. We had some problems with these USB drives, which is now hopefully fixed. It does not work as a wireless router. So these were originally wireless routers. That functionality is not enabled. They have the same functionality. We are actually for the version 4 probes, and I think backward also for version 3 probes. There's a project going on about wireless measurements, which actually measures things like eduroam. So eduroam is quite widely deployed, of course, and for us it's another chance to get probes into networks where we are not yet deployed. So measuring if eduroam works, these types of wireless measurements are planned for these, but not for these anymore. In fact, these will be slowly but surely deprecated. We'll do like security updates on them, but not new types of measurements because they're simply too constrained an environment for further programming. And then we have, of course, these anchors. The big devices, and that's it's a server, so it has the performance characteristics of a server type system. Searching for probes. So if you go to the interface, let me just go to the interface then. Go to atlas.net. So here you go to probes and anchors, go to probes. The actual URL is atlas.net/probes. I typically don't do this clicking, I just go to probes. Then you just have like a search box for probes. These are So this is my home probe. So you can actually see all kinds of, you can see who's sponsoring your probe, because like, or maybe that's because I'm an advanced user. You can see how many bits and packets your probe sends, the uptime. You can see I live in the beautiful town of Haarlem. The geolocation actually is a bit fussed, so this is not where I actually live. I live a couple hundred meters away from there, but the system fuzzes this to protect the privacy of the users to the extent where it's useful. Yeah, maybe. So this is a Pro version 1. It's a small one. You can see firmware version. If sometimes it's useful to know this firmware version because the measurement results can be different based on the sort of new feature are added to specific firmwares. This is user-provided information. I did not set bandwidth limits. You can actually set bandwidth limits if you host one of these devices. You can say no more than this much bandwidth. You can specify a DNS name for it, so you can actually ping it based on a name, not on an IP address. It's shared publicly, that's the default. People can have private probes. We'd rather not have people private probes, because then the IP address is not visible externally. There's all kinds of other restrictions that some people want, but it's against the open and transparent type of measurement infrastructure that we want. And then there's user tags. So, so let's first start with the system tags. So the Web Atlas system itself tags these probes with certain things it can know about the probe. So V1 means this is a version 1 probe, resolves A correctly. So it is able to resolve a DNS A record, so a name to IPv4. It also does name to IPv6. IPv4 works. From the measurements we determined that this device actually can do IPv4. IPv6 works. With the capables, capable means there is an IPv6 address or an IPv4 address configured on the device. But the works actually looks at the measurements coming out of this. It is in RFC 1918 space, so it's in private space. So from this you can infer that it's probably behind the net. The IPv6 has been stable for 30 days, stable for a day. So if you want to select stable probes, you can later, when you specify measurements, you can use these tags to specify specific probes that you want from the system. So there's stability here. You have this, for instance, this is interesting. You have the V6 was stable 1 day, 30 day. V4 is stable 1 day, 30 days, 90 days, but I don't see a V6 stable for 90 days. So my V6 apparently in the last 90 days has been unstable. So I learned something from my probe page today. You can share your probe with other people. You can have notifications, and you can transfer it to somebody else if you want to. So network information. That's my public IP address. That's my the autonomous system the probe is in. In IPv6 the same autonomous system it is in. Let's see what else. Here you can see how stable it is. It's 99% up. It's 92% for the whole 6 years that this probe has been connected. And here you actually have a connection-disconnection log that you can also do fun things with, right, Anand?
Yeah. We'll hear about it day after tomorrow.
Yeah. So you can actually use that to look at disconnections of networks and countries even. So that's research that Anand has been doing on this system. Let's see. So we were searching for probes. but you can also go to, okay, 1213 is the HEA net, which is the network we are in right now. So let's see, we have, I don't have any probes here. Oh, this is the, let's go to the public probes. So there's one in the Hamilton Institute. So this is how you can sort. So this thing is actually 100 meters away from here. This probe, that the page you're actually looking at, and it's up. Yay. Okay, that's searching for probes. Yeah, so you can country, locations. There's descriptions here. So if somebody put a nice description in their probe, you can actually use this web interface to look for probes. Oh, nice. You can also use the API to look for probes. And I think this one is an interesting one to actually also. Let's do it like this. So to get you demonstration effect. What it should look like is this. So I don't know why this didn't work, but here you have all kinds of the fields that you can actually filter on in the API. So I'm going to try again. Reference. Do it like this. Okay. Probes. Oh well, this. My apologies. This didn't work. There is an API reference. I'll change it in the slides where you can actually play around it, sort of in a form on, for instance, filter by country or filter by. You can actually do like this coordinate. Give me all the probes within 50 kilometers. That's, for instance, a nice thing to. If you're looking at a specific city, say you want to look at Dublin, or you can just say, give me city center of Dublin and all 50 kilometers around it, and you have a set of probes that you can do interesting things with. For instance, for an outage for Amsterdam, we looked at, for instance, you can center of Amsterdam, put a radius around, and then just look at these probes. And this is what the results actually look like in JSON. So this is stuff you either have to parse yourself or use a library. So it's things like that's the so we get an IP address of all the probes, the public IP address, and we get a private IP address. We infer that the public IP address, we look at the routing table. This is the actual prefix that this probe is in, so you could aggregate probes by prefix. The status is since 1620, that's today. So my probe was actually disconnected 6 o'clock this morning, and that's something that these V1 probes do very often if they get memory corruption or something happens. they just reboot and restart, and that's the way we deal with that. So the newer probes are actually far more stable than that. So the status ID is 1, which means it's connected. Well, this actually is probe number 1. The ID of the probe is here. So this is where so you can actually see it's a lot of information about a single probe that you can get, because this is actually my boss's probe. Yes, probe number 1. So he had put a description in here. He is also with access for all. He put the tags in. Oh, I forgot to tell. You have the system tags, you have the user tags. The user tags is what the users put in about the probes. So they actually have a name and they have a slug, and a slug is the thing that you use in the API. So if you want system version 1 probes, you say I want probes with the tag system-v1. We'll get back to that later. But for instance, this doesn't have a system, so this means that the user put in that the probe is behind the NAT. User put in the probes at a home. The probe is at a DSL connection. User said the probe is on IPv6. You get a geometry. This is GeoJSON actually, so if you're a geo person, you could actually use this in all kinds of GeoJSON things. It's a probe, these are the addresses, the uptime, the country code, a lot of information. Is anchor, says that this is not an anchor. So let's get back to here. So yeah, that's the probe page. Important that that's set by. So you can define your own user tags. So if you want to have a group of probes that a group of people want to measure something, what you can do is user group X. You all set that probe, and then all of you can use the same probes by user tag to start these measurements. The nice thing is that if users are added or users are removed, you could actually specify stuff in the measurements interface to actually accommodate for that automatically. Yeah, set by probe host, set by system. Yeah, I showed you. All probes have an ID. So in the UI, they're very, very logical, the names. So this is, in the UI, that's the API information about the probe. The command line, Ripe Atlas probe info 4, can actually show what Ripe Atlas probe info 4. That's what it shows you. It's just the same information. So if you're a command line jockey, it's also useful to have that available to you. Little trick, the probe types are embedded in the IDs. So under 6,000 is a V1 or a V2, 6,000 to 10,000 is anchors. So these big devices, over 10,000 is probe V3. So from the IDs you can actually immediately see what versions you have and what characteristics. You could easily filter out stuff there. So interesting question. Do we have these probes where the users actually are? So we say we are in 10K or 9,800 probes, but are these probes where the users are, or are they where the servers are? Are they representative of the whole internet? And this is a really hard question actually, because what's representative? What's there's a Petros Gigis, he's from Fourth. He's a student who's actually worked on this. It's an idea to actually look at, if you look at ISP's market shares and compare that to where Ripe Atlas is deployed, So if you count a single probe in an autonomous system as we cover this autonomous system, and if you then have numbers on what the market share of that autonomous system is, you can just say, you can just accumulate all these numbers for the networks where you have probes, and then you can say RIPE Atlas covers the networks of 80% of the users in a country. So that's the green countries. Greenland is green, but that's just because we have, I think, 1 or 2 probes in the incumbent telco, which has 99% of the market. So then you cover all the users. So that's sort of our definition. I mean, it has lots of fine details that we don't go into per se, but then you look at Africa, and we don't have a lot there. It's really hard to get probes deployed. Especially internet is metered, and then, yeah, why would you give some of your precious bandwidth away to a measurement project? So that's a much tougher sell than doing it in Greenland or all kinds of other countries. So that's the map. I also want to go to that URL for a bit, because then we can actually dig into. Is there any country you want to see particularly?
India.
India? Cool. So you can actually, what I would like people to do is look at a country that they're either in, or that is their home country, or the country of their institute, and actually see if there's networks there that you can get a probe into. If so, I got 10 here. So I would really like these to go into these networks. So we make it better for researchers, for operators. India. See, we have, that's the number of users in India. That's the percentage of networks, percentage of users that are in a network where we have RIPE Atlas probes. So I actually go to India. So you can actually see green here means we have probes, white means we don't have probes, yellow means we don't have enough probes, it's less than 3. So if we lose 1 or lose 2, then we're gone. So Reliance has 38% of the market share. These market share numbers are actually from our colleagues at APNIC, and they're estimates. They think they're correct within a couple of percentage points. For Ireland, they're way off because Facebook is totally destroys these statistics, but that's a different story. BSNL, that's the incumbent-ish there, has 10% of the market. We have probes there, so we can measure from there. Bharti, mobility. So mobility is a problem for us, so that's why it's nice that there's something like Monroe, which does mobile measurements. We typically don't, because we're attached to, you have to have an Ethernet in there. Airtel, we have 6%. So I'd really like people to go to their home country, institute country, figure out if there's something that says 0, 1, or 2 here. If so, please consider putting a probe into your network, into these networks, because that's where the system only gets better for everybody.
So for Reliance Jio, which was the top one, do you differentiate between the mobile ones and the home broadband?
We do this based on ASs, and which is hard enough already.
Yeah.
So I would love to do all kinds of other differentiations, because the critique to this, of course, is a single AS might have multiple service levels, might have multiple, you have like islands of connectivity. There's all kinds of, an AS is not a single, it's typically controlled by a single entity, but it's not that it's a homogeneous thing. So if I measure NTT from Japan, it's different from NTT from South America. But it is a first point of sort of differentiation. If you know what ASs have in large user populations, you can actually go into representativeness of users for RIPE Atlas. And this is only focusing on users, right? This is not focusing on the Facebook, the content, because well, for one, content is easier to measure towards, but it's also harder to get devices in these networks, typically. So anchors solve a little bit of that, but not all of it. But you don't care about probes really. You care about measurements, I think, because that's the product coming out of these. A probe in itself is just a means for a particular purpose, right? So what these devices actually do is built-in global measurements towards root name servers. And some people have successfully used this for papers. So anybody done a paper on this type of stuff? See? On the website we visualize these as internet traffic maps. What the anchors actually do is they are a stable endpoint in the network for measurements inbound to these anchors, and you can use your credits to run customized measurements on all of these. You could actually see the system as a, well, Alberto explained looking glasses yesterday. This is a very distributed looking glass. You could see it like that. You can, in any point here, you can do a ping, a trace route. You cannot do a BGP lookup, unfortunately, but and well, I mentioned the types of measurements already. This is the term measurement is quite ambiguous actually. So it could actually mean this is a specification of how you want to measure things, or it could be measurement results. And somehow we keep mixing these terms up. So what I want to talk now about is like the measurement specification. How does RIPE Atlas, what's a unit of measurement? Because I think in many people's heads, a measurement, for instance, a trace route measurement. What is the trace route measurement? It's a single source to a single destination at a single point in time with specific parameters. But for RIPE Atlas, it's a number of sources. Could be one, could be all the probes in the network, to a single destination by hostname or by IP. So, and actually, if you do it by hostname, it could actually be multiple destinations, because if you you can actually specify that the probe resolves that hostname, and for things like Google, Apple, you get many different hostnames. You specify a protocol, IPv4 or IPv6. And you specify a given measurement type, ping, traceroute, DNS, with all kinds of things. And you do it with a given interval or as a one-off. So you say every 30 minutes, every whatever you specify. Or you say, give me this measurement result as soon as possible, which is called a one-off. So that's the interfaces for measurements. There's the UI, which has nice visualizations. This is just the overview. Here, if you have a specific measurement ID, again, all these things have an ID. If you specify measurements, which we get to later, you get an ID. Then you get a nice visualization. API, of course, you have, this gives you the measurement specification. So this is how the measurement was specified. It gives you all the parameters. And this actually gives you the results. So this gives you back a JSON structure with this measurement from a specific source to a specific destination at a specific time. Command line interface also allows like measurement info and report are sort of the things where you can quickly look. If you're a command line jockey, what sometimes is nice that you use like this results thing, and then use something like JQ or some kind of JSON processor to quickly get results. that's what the user interface looks like, and let's see how am I doing in time. Yeah, so for instance, this is a trace route that I specified. You can actually in the UI see it's a trace route, I own it, the credits are charged to me, it's a public measurement, this is the target. If you specify a host name here, this field is important, because if you don't specify resolve on probe, the RIPE atlas system itself will do a centralized resolution. So if you actually want to look at how is DNS resolution different in different parts of the world, and this is important for the lab, hint, then you might want to look at if the probe resolves on the host name or if it's centrally resolved. Interval every 300 seconds, so this is how long the measurement has ran, so this ran for an hour. This costs 30 measurement credits per result, that's the daily count. So there's all kinds of parameters you can set. This was actually 5 probes. I asked for 5, I got 5. So you can actually see which probes. You can actually see, for this particular measurement, I specified the autonomous system for the probes would be these. These are the round trip times. They did not reach the destination, and there were 15 hops. You can see the probes on the map. So I think I specified Switzerland for this. Well, map doesn't load. And so this is the nice tracemon visualization again. Here you can actually see it doesn't reach its intended destination. And there's 3 or a couple of probes here. There's IXPs, and after the IXPs it fails. You can actually see that AS2914 entity is involved somehow, so this allows you to dig into your measurement results. This is interesting because we have a geolocation database for infrastructure IP addresses. I've seen too much research done with MaxMind and other open geolocation services, and unfortunately I don't know the actual accuracy, I just know it sucks, it's really bad. So it really hurts me if I see really good research done based on wrong assumptions on geolocation. And so an attempt to fix this is to crowdsource this information. So I built a really simple interface that actually gets you a sense of the actual geolocation, but it's crowdsourced. So it's Wikipedia, information in here can be wrong, but network operators have OCD, so they try to fix things and they try to make things right, and that actually is something we use here. So for instance, this is a visualization of this trace route. You click onto here and you actually get, we can actually do one. Is this one in London? RTT wise it could be, so this means this was geolocated to London, and NTT is very accurate. This one is Frankfurt, so we can actually say Frankfurt. And now we've added to our geolocation database in that we now know that this IP, this host name, is in Frankfurt. The system collects that. We've seen it in a trace route that this is pretty accurate. So that's another part of the interface. And let's see. I have to reload because and here's where you can download the actual measurement results. We will get to that. So anchoring measurements, hundreds of probes towards right atlas anchors. So that's these are sort of like, I like this picture for, these are the anchors, and there's like the Japanese garden stones around it, sort of. These are the rocks of stability in this fluctuating internet, and these anchoring measurements try to capture that. So it's hundreds of probes towards right atlas anchors. They do pings, trace routes, and DNS measurements. And all the anchors themselves do a mesh. The anchors will mesh. Oh, it's pings, trace routes, and HTTP. It's nice that I put it on the slide. So that's what you also can use for if you want measurements from the system. There's specific APIs for the anchors as a specific type of probe, and anchoring measurements as a specific type of measurement. That's where you can find all that information. Another thing, before we go into how to actually specify these measurements, if you can use existing stuff, there's a lot of stuff in the system already, and yeah, maybe it's a bit hard to find, but there is a lot of stuff that's already done. There's interfaces to this. You can search for existing public measurements, and if you don't find it, only then specify your own measurements, because otherwise we get a lot of redundancy in the system. Or if you have good ideas on how we can make this data more searchable, or like maybe have a hybrid of somebody saying, I want to have this measurement, then before actually doing the measurements, people could figure out if part of what they want is actually done by the system already. So that's the measurement specifications. This is about the creations. First, credits. Who here is not a credit millionaire by now? Okay, so you didn't get the measurement. Okay, we'll fix that in the break. So you all are, almost all are measurement millionaires right now. So you can actually do measurements on this system, and we have this system in place for fairness and to avoid overload. This is a system, you can overload any system, and it has been overloaded at least once. So that's why you need limits on what people can do. So it's a really simple scheme. A ping costs 3 credits, trace routes cost 30. If you do one-offs, it costs twice as much because it stresses the system a bit more. So that's how it ensures that the system doesn't get overloaded and people don't do just crazy stuff. That said, we can extend these limits for anybody who has a need for it. But then we try to stress how that the system can be overloaded. There's auto spending limits. There's a maximum of measurements you can create. This is all documented on the web page. So you can run into these types of limits. If you do, come talk with us. We have a public mailing list. You have my email address on all of the slides. So don't be shy to actually talk with us about extending these limits for certain purposes. Especially if it's useful for network operations, then if you can make that argument to us, my research is important for network operations, then it's really, really hard for us to say no. Yeah, so hosting these probes, you earn credits. That's the typical way that people get measurement credits. Or you become a sponsor of the project. You get extra credit if you're a member of the RIPE NCC, you get 1 million credits as well. You can host an anchor. Anchors get, I think, 10 times more credits than probes, and you can sponsor probes. So there's all means to sort of incentivize people to participate in the system. That's another thing with the credit system. how to create, user interface. There are many options per measurement type, so this is a part where I would invite people to actually dig in to see what's actually possible, if the system does what you think it does. So when you create a measurement, you get one of these IDs, and that's sort of your tracking number, your DHL tracking code for well, to track the status and to download the data. So this is what the UI looks like. So well, you can find it in the menu where I found probes. You can find measurements. You find, if you're logged in, you find this form. You create a new measurement, and this is a ping measurement. So just target. Well, it's a web form. This is not rocket science. Resolve on probe again. That's an important one, because the default behavior is that the system does the DNS resolution for you. So it's going to be a single result from Amsterdam. So the system is physically in Amsterdam. So whatever is resolved from Amsterdam at that point in time is going to be the thing that all the probes are going to be doing. You select probes. You can, if you use the wizard, you get a nice world map where you can actually select or autonomous systems, or you could just do a box selection of, I want this box of probes. You could just specify measurement IDs. You can also reuse measurements from another. You can use the set of probes from another measurement, so it just does a copy. You select the timing. You select one-off, which is more expensive, or you do a start and end time. You have specified in the previous part, you've specified a periodicity already, if you do periodicity. And then at the bottom of this is really useful, I think, is a measurement API compatible specification. So here is a definition of what the JSON to make this measurement run looks like. And this JSON you can actually use in the API as well. So if you are just figuring out what measurements you want to do, this is a useful way to look around, see what the system, what parameters there are available, and then use this definition. And then if you want to do 50 variations of this measurement, you can just use this specification. Or copy to your clipboard even. So so if you use the API, first of all, you need an API key. There's all kinds of capabilities. If you want to do them from the API, you have to specify a key, and that's something you create yourself, and it's a random string that identifies some capabilities that you want a particular script or a particular post to do. So you specify a key for creating measurements, and that's just a string. And when you do a post request to the system, you add that string to the post request, which makes the system recognize that you actually are allowed to do this. See, this is key equals your key here. What's probably easiest is to do this via the Python library Ripe Cousteau. This is actually, the documentation is, after using the system for many years, I still go to this page to actually get my useful snippet of this is how I specify this with Ripe Cousteau. So if you want this type of access, this is your, or at least it has been my savior for, or a big time saver for a lot of times already. So that's an example. So this is Python. So I don't know if well, we did Python yesterday already. So well, here's your key. You specify a ping object, address family 4, target, description, a trace route, is a traceroute object, so that's like the measurement specification of this is the type of measurement with these types of options that I want to do. You specify sources. In this case, you specify 50 probes from the Netherlands, and you specify tags. So here it says exclude system anchor. Little tip here: if you say requested -1, that means get me all of the probes of this particular type. So for the Netherlands, you'd get, I think, 800 probes. So it's a lot of credits that you're burning if you do that. But it might be nice for small autonomous systems that you want to measure, that you just you don't have to count how many there are, or you could just over specify. If you say 100 here, and there's only 3 available, you're only going to get 3. And then you actually create a request. It has a start time. The key is filled in. The measurements are here. The sources. So it's actually actually it's 2 sources here. So you can we do 2 measurements, and both measurements have 5 worldwide sources and 50 Dutch sources. And this is a one-off, so we just do this once and be done with it. And then you get a success response. The response actually contains your measurement ID. So that's how you would programmatically specify this. So the results. You retrieve them either by measurement ID, the measurement results. There's a streaming API, and this is a new thing that I had hoped to get ready today, but we didn't. So we're almost there that you can actually download data from us. Sorry?
It's available. It is available.
Is it available? Is the article out?
Now, yeah.
Okay.
We're already downloading everything.
Okay, cool. Because I hadn't had.
It's the most recent ops.
Yeah. So, but okay, cool. So we actually have it available. So my colleagues are surprising me that we wanted to have it like as a new thing for this. And yesterday we were, we're gonna do it, but it actually happened. I'm happy. So we have measurement ID. So this is how you do it in the UI. I showed you there's several tabs. One of the tabs is measurement results. You can just get your measurements from there. You specify start date, end date, and you specify if you want to have it as a real JSON or a fragmented JSON. So that's, I think that's a nicer format personally, but that's every line contains a single JSON. So you don't have an array, so you can actually more easily use it in a sort of streaming type of environment where you. So if you have a real JSON, you have to wait for the end before your system can parse it. So UI also has other visualizations. I showed you these. API has results. This URL. So we could actually plug in a, let's plug in that measurement that we just had, which has, oh yeah, so that's what it looks like. So yeah, big JSON blob with what does it have? Destination address, an end time, Paris traceroute ID. The probe ID that was from and the result. So this is a traceroute, so it has an array of this hop, first hop has this IP address with that RTT, that size, and that TTL. So it's for a traceroute, it's quite an elaborate structure. So you can use Sagan to parse that, or do it yourself and find all the interesting things contained in here. Maybe an interesting one is LTS. That's the last time the time source was synced with our system. So sometimes these clocks get off, especially these probes keep doing measurements even if they're disconnected from our infrastructure. So, and at that point, they might not have a clock signal. So if clock signal accuracy is important to you, then this LTS thing is really interesting to look at. And we have a command line interface as well, report measurement ID, and that just gives you a parsed output of for traceroute. It will actually give you something in a traceroute type format. Streaming, so that has a publish subscribe through WebSockets. It gives you near real-time data. So, and there are actually two types of data. There's measurement results. So you actually get the measurements as soon as our system is able to give them to you. You also get probe connection status events. So probe goes up, probe goes down. It connects to our infrastructure, it disconnects from our infrastructure. And again, that's the work that Anand, this is actually going to be presented at TMA. So if you stay for the conference, you're going to see a nice paper that actually uses this to figure out if particular parts of the internet are disconnected. Because these individual probes can actually disconnect for random reasons, but if there's a burst of them disconnecting, that's an interesting signal. So you can monitor that near real time. So for instance, if you run a network, you could actually look at if all probes from your network go down at the same time, there might be something going on. You can also do nice filtering here. So just give me all the measurements between this date and that date. Give me all the pings, all measurements towards a single. You want to have all the measurements towards Google 8888. 8888 is the most specified destination for measurements in the system because it's such an easy to remember number. So there's a lot of stuff in the system to 8888 already. So don't specify measurements towards 8888. They're already in the system. I can assure you, because I think I'm one of the people that specifies all the probes to 8888 trace routes periodically. So you should be able to find that. There's some nice documentation about this streaming. I only got 10 minutes left, so I'll speed up a bit. So this is the cool thing. This was, I think, for researchers, the most requested feature is just give me all the data. Don't give me all this stuff. I know what I'm looking for, or I just want to do exploratory data analysis, and then you don't want to deal with these measurement IDs or because if you want all the data, you have to know all the measurement IDs, and you have to sort of one by one get them. So it's possible to actually get the data, but it's not trivial, and it loads the system a bit. We've actually done some things with researchers where we actually shipped or actually took a terabyte disk with as many trace routes as possible, and just fly to a research institute and actually hand it off to somebody so they can actually do their analysis. We don't have to do that anymore, luckily. So we have the same student who's working on Petros. I just heard that it's available, so I don't have to try to wing it. That's where there's 26 files there which have like by measurements type, by either is it a built-in or the custom measurements, and there's some differentiation. So 26 files per day. So if you want to have all the trace routes, just download all the files there that have trace routes for a given day, and put it on a cluster and knock yourself out. And this describes actually a couple of how it's actually done. And I'm actually really happy that this is available, because that gets hopefully gets a bit more use of this data in bulk. We do have an internal Spark cluster, so if people want to do fancy things at the RAP-NCC, that's also a possibility, but it's much harder than you just download and knock yourself out in doing cool research on this. So We do have some other stuff at this FTP. We're an old organization, we do FTP. There's a probe archive where you can get a daily dump of this is what the JSON for the probes look like at a specific time point for every day. So you can actually track changes in whatever for specific probes or do the bulk. I've actually been, this is unfinished research, but been looking at when do probes change their AS. Is that a signal for maybe they should update their geolocation? Because people actually moved, because we've been running the system for 6 years and it's impossible that nobody in 6 years moved. So there's all kinds of gold in this, in just these dumps already. And we have a measurements archive, so that's the specifications of all measurements, and we also dump that, I now forget if it's daily or weekly, but you get a long list with all the specifications of all the measurements ever done in the system. So you typically needed that to download all the data for a specific date, but now you don't anymore. But this is still useful for figuring out if you want to do your own search and not use a search interface. You can use this to figure out which measurements from the system are actually useful to you. So, well, I guess I'm okay with time now. What's important for us also is like a community around this system, because it's a system built for community by community. We have nice Ripe Atlas t-shirts. We have ambassadors, so that's people who help us distribute these things, especially in places where it's really hard to get these devices installed, like India, for instance. That was a good example. We now have a couple of people active in India that we just periodically send 10 probes, and they look at our interfaces, see, hey, they're active in their network community, and they just give out these probes to networks where it's useful. So if you're interested in that, come talk with us. Developers do free and open software. Network operators create measurements and monitor their own networks, and this is where this crowd is, I think. Well, you use it to better understand the internet and hopefully make the internet better. So if you want to participate in this community around Ripe Atlas, of course, use it and give us feedback. What does work for you, what doesn't work for you. We'd really like to hear if something works for you or not. If you have crazy research ideas and don't have the credits, or the system doesn't do what you want, talk with us, because then we can see if we can do something with your wishes. And if you have done something, share your research. We have a platform called Ripe Labs, where you get a whole lot more exposure, typically, for your research, and you get a chance to let network operators actually read this, and they can give you valuable feedback on this is useful about your feedback, this is not useful about your feedback. And it's actually one of my tasks for TMA is actually write something about TMA for Ripe Labs to actually see if we can find the research that we think is useful for network operators, and so network operators can also give you feedback on what you think is, or what they think is useful in what you did. You can come to our meetings. We have Ripe meetings twice a year. We have regional meetings. There's a program called RACI. I will have a colleague called Gergana at the main conference. She's in charge of this program. So this actually gives you travel grant to get to a Ripe meeting. Wait, has any of you ever been a RACI? Oh yeah. So you can ask him how it was in a break maybe, or maybe if you want to say something about it. I'm putting you on the spot.
It was great. I can only recommend it.
Okay.
I was never at a Ripe meeting before, so it was really good seeing the operator perspective.
And we have nice T-shirts
Yes,
at Ripe meetings. See?
True, yeah.
you can also participate in we do hackathons, which is also a great place. So any hackathon participants here? Oh yeah, of course. So I really like these because it gets researchers and operators into a single room, visual people, all kinds of, and wonderful things just happen. We're open to collaborations, internships, so anything, just let us know. So that brings me at this. Questions, remarks? Was this the type of Ripe Atlas tutorial you wanted, or we have 5 more minutes to go into details about subjects that you would want to be talking about?
What are you expecting from us in terms of research? For example, yesterday you mentioned some things around statistical analysis of your data.
Yeah.
What would you be expecting, and how can we work together?
What I'd like to focus on is sort of this get the operational relevance to research and get research to make the internet better. So show stuff that is not working and show how to fix it. And that's like this, I think the stuff that network operators want to hear. So that's and it's just, I don't know per se what it would look like, but just getting to talk, and like the conversation we had yesterday was about like how round trip times are not normally distributed, whereas all like ping has like if you use the ping tool, it has an average in there, which is, yeah, I don't have much of a mathematical background, but to me that doesn't make sense that it has an average there. So how can we make these types of things better? What's the distribution of RTTs? And if you're then making the step back to what does this mean to operations, because these are potentially complex things. Can you translate that to like technical people who don't have necessarily the mathematical background? They're typically smart people, but don't have this background. How can you translate that back and give them something useful that they can use in their day-to-day practice? So, for instance, anomaly detection. It's like if you have a normal distribution, or something that is totally different, it becomes a different ballgame. Sort of trying to understand these types of things. That's for instance, I think a very useful conversation to have, or fascination by network outages, and that's also something shared with the folks at CADA, and we have been collaborating on stuff like that. That's the type of stuff that we think is useful for network operators, and so we can also help in getting you in contact with network operators to see if the stuff is actually useful to them, or what they actually want to, or you see something specific in this network but you don't know who to contact. So this is also like researchers want to understand something, preferably without having to deal with this. There's a lot of complexity involved in actually getting to talk to the right people. So that's why you rather just observe the phenomenon than actually spend half your day chasing people to actually figure out if what you see is actually what is happening. That's another thing where we can help. Does that answer the question a little bit, or? Yes.
Yes, I want to ask how these credits are updated for those people who are hosting probes and for those who do not.
Well, the people who host the probes, they just get extra credits in this.
After how much period?
There's a short delay. It's in the order of minutes or hours, or
Every day? Once every
sorry?
Day. Once every day you get the total for the day.
Okay.
I think.
See, you should have done the lecture. No. No, yet I know that it's periodically calculated and it's just added to your account if you host a probe. If not, then they don't expire. So the million you get now you can use up now or
And once
in 3 years.
if they are finished, then like if this million is finished,
Then you cannot specify new measurements. There is some leniency towards running measurements will continue running for a little bit until they are actually stopped. But we hope that you either like if you have like a research that needs this continuously, then we hope you talk with us on how to extend this or host a probe or do any other thing that gets you measurement credits. That answer the question?
yes.
Yes.
Maybe I missed that part, but what is the difference between anchors and probes in terms of capabilities and the duties in right?
So the difference between anchors and probes. Yeah, the anchors are specifically meant as an inbound measurement. They also have some specific DNS zones installed on them. Yeah, I didn't explain that part. But they are far more powerful. They also do a lot more measurements. They do this mesh between themselves. The probes do measure inbound to the anchors already. That's implemented in the system itself, so you don't have to do that yourself. But they're just, well, they're one-use server type hardware versus these little boxes. So that's I cannot give you like quantitative this much more, but it's much more. That's but we can look into that if you want to know more specifics. You can look into that if you. Does that answer? Okay. Yes. Last I looked, it was like the order of 40,000. So it's far from complete. But we're actually working on a production first. So what I typically do is I build prototypes. I show something is possible, and then if it's successful, then people make a production version of it. And we're actually making a production version of this. So there's 3 people actually working on making a way better version of that. So and well, the first version. Well, there's all kinds of interesting things like Anycast on geolocation, but then that's all stuff that they will gradually implement. So if people are interested, and for instance, Corinne has been doing some interesting research on geolocation. There was a poster here. That's your poster. And we're actually looking into implementing that into OpenIPMap as a production service further on in the roadmap, and also talking with people at CADA about drop DDEC, the hostname rules, how to implement that in a system like that. So that's another way we try to collaborate. So if there's really nice research going on, we are tasked to sometimes build these production services that are going to be used by network operators, and your research could actually go into that. So that's another way to collaborate. To come back to your question. More questions? Okay. Then, so this is the, well, I'm 5 minutes into the break already, but you didn't stop me. So for the lab, Corinne is actually gonna join me for that. He's been doing the preparations for the lab, and I'm really grateful for him stepping up doing that, because I think it's a pretty nice, it's come together pretty nicely. You have this voucher, so you need access to the system. You need to get the voucher, and you can actually see if you have the credits there. What I want people to do is think of a country you want to measure from in the break. Either your home country or some faraway exotic place, so you can say I did measurements from Jamaica, or and it would be nice if we sort of split it up. So there's a lot of Italians here, a lot of Germans here, so maybe you should not all pick Italy or Germany for your lab. So I think that takes us to the break, right? So I hope this was useful to you. And if you have questions, my email address is on there. I'll be around for today still, so please let's talk. Okay, thank you.